Welcome everyone to first Qlik user group this year. I'm glad to see so many familiar and unfamiliar faces. So we will spend some time later also to get to know each other. Let's quickly go through our topics today. This one we are running today on Thursday, but we have an idea to move this event to Wednesday. We will probably have a quick quiz in the end asking what is the day, what would be the best day for you. But yeah, we will see how it goes. At the moment, Wednesday is what we plan, but we will see what you say, yeah, because it's up to you. All right. What are the presentations today? You already see me. I'm Sergey Makushynski, if someone doesn't know me, and I work at Qurious Solutions. Then today we are going to hear from Qlik, from Ajay Kumar. He will do the presentation about what new in the Qlik world. It's not just in Qlik, it's in technology, but what's happening in general. So then Boon from Boon Solutions will talk about Apache Iceberg. And after that, Justin from IGO will share what they did with QAQC. Yes, okay. We will see what it is. I'm quite excited about it. Then at 5:45 roughly, I think we will finish, and from 6 p.m. we will go downstairs to James Street Bar for some quick food, drinks, and networking. How does it sound? So in this instance, Jay, it's over to you.
Hi everyone.
Yep.
So I'm Ajay. I'll go off the video now. I'll continue on the slides for you guys.
Yep.
So I'm part of the partner enablement team in Qlik. Along with me, we have Satish, and we also have Jeff, who are actually physically. Sorry, I couldn't join you guys this time as well. So next meetup, I'm sure I'll make it on. So moving on, today we will be having updates on what's new in Qlik. So since we met last time in November, so there are quite few updates. So I'm going to walk you through in. So before I go in, the first thing is we'll be having a disclaimer. So Sergey, the next slide.
Yes, it's on the screen.
Yeah. So I have a legal disclaimer here because some of the product or features which I'm going to discuss today is getting launched or in a roadmap. So it's a standard legal disclaimer. So if you're expecting the product or if you're testing it on, it may not be there. Yeah, we go to the next slide. Thank you. First, before I go on to the new product, so I want to give some notification on some of the products are like kind of some of items which are like getting live or like kind of the products are no more available in the market. So end of December last year, so we have stopped selling the Talent CDC because after Qlik and Talent become a single entity. So Qlik Replicate is getting the full focus. So if there is any existing Talent CDC customer, so they are having an end of life on the product line, and Qlik is helping them to get into the Qlik Replicate CDC portion. And for analytic users, if you guys remember, we had a Podium, which is Qlik Catalog. So that is also end of sale because now we are having the Qlik data product catalog. So that will supersede this product line. So any customers who are in the Qlik catalog are getting notified individually, and we are talking to them on how they can come into the QTC, which is Qlik Talent Cloud. So if there is any renewals, that's still going on, but eventually everyone will come into the Qlik Talent Cloud. So moving with the next slide, where I'm going into the new features that says released in the Q1. So from the analytics side, we have data flow. So for the QlikView developers, we always go to the load script. That's the lovely thing we always like it on. But sometimes before, if you guys remember, there is something called Expressor. So now we have the data flow, which is more than the Expressor, which helps to do the visualization. It is available in the cloud, and it's already there in our AP region and many of the users are already start using it. And we have few micro video which says that how easy it is to convert my script into the data flow. And on the integration side, I want to say we have over now with Databricks. So that's something which was stopping some of the users where they wanted to, instead of entering the token information, they want the authentication for the Databricks. So that is available in the cloud. And when this is getting rolled over, some of the automations which are like a third party runs is also available in the QTC cloud now. So eventually those are from the analytics and the integration side, what's new at the current point of time. So now with this new feature coming in, when I'm moving on with the entire cloud, Sergey, next slide. So I want to put it out round the clock, like what are the things we have in the cloud? What are the features we are having? Okay, I think they went
Sorry.
on the show. Yeah,
Yeah.
okay. Yeah, thank you. Yeah. So what are the things we are looking on is what are the benefits the users are getting in. So I'm going to go it anti-clockwise. So starting it as we are in the worst. So it starts with the cloud platform capabilities, what we have in, and AI ready capability, what we have in the cloud, embedding.
It's automatic.
Okay, I think, sorry, some problem in the cloud is fine. So these are the key capabilities on the cloud. Later, I will share it with you guys. So the main things which I wanted to focus here is that once the data is ready, we move into the deployment model. Sergey, we can go to the next slide on.
Okay. Thank
So
you.
on the deploy,
It really
yeah,
wants
I'm
to
fine.
show
I'm
the
fine. Yeah.
next slide.
Yes. Okay. So now we are talking about the deployment because we need to get it ready for the business users. So what are the key initiatives from the pipeline perspective? And I'm going to for the deployment. So I started with the different sources. It can be your cloud source, on-prem, SAP, if it is a legacy mainframe and data sets. How I'm going to take it into my end use cases. So the end use cases are something which we are actually talking in the previous slide. So I bring it up as a checklist where we're going to talk on what are the end users these days they wanted, or what are the key business initiative that is being taken on. So starting from any source, any target. So that's basically that we have the huge set of source and target in our Qlik data factory, or like kind of a single place where you can put it on. And people talk about real time and near real time. So real time is where we see the CDC coming in picture. And we also have something on streaming capability. Later, Boon will be going much deeper onto that. So I'm not going to touch base on now. And also we comes into the how easy I can automate and get the informations across. So all this capability, we are focusing on basically on the individual initiatives where the business wanted to get the maximum from their raw data. This key initiative to the next level when I'm proceeding it on. So the next set I'm looking it on is once I have the Sergey, on the slides. Yeah. So I'm going to put it on how the different sectors are going to get in picture. So from a BI sector, if I'm going to talk on, because analytics comes in the picture, so I'm talking from the BI perspective, we're going to do the move transform, and then we're going to have the trusted score. Eventually, the data is going into the warehouse and all the data engineers are going to use it. So that is the basic where we have the report dashboard and visualization capability coming in. The second set is on the ML capability, where is the predictive capability coming in, where people still go with the warehouse. However, the data scientists use the data for the future prediction. So there comes multiple ML models and the capability. So some of the use cases even go with image recognition, wherein your CCTV footages can be getting into the DBN getting in, and churn prediction is the very simple customer use case. Wherever I go, I use that as an example because that's something which the management wanted to know. Because instead of getting a 100 new clients, so they wanted to retain their 10 existing clients. So that's something which everyone is looking at. So the third one is on the Gen AI capability. So now we can say that there is everyone have Chat GPT in their mobile, and they want to be like kind of like looking at all the AI capability at the fingertip. It can be like, and multi-scale hyperscalers are doing it in a very effective way, making like every releases coming in and smashing in the prices. So Qlik is like not behind; it's always catching up on the capability, and that's where all the Qlik answers capability and also unstructured data capability use cases coming in the picture. So now to get all this trusted information on, so my platform need to be secured. So that's where I'm going on with the next slide in. Yeah. So the Qlik Cloud Platform. So now we have the region close to 8 years now. All the certificates and all the compliance, it's available. So it's moving on to the next slide, where I can talk about what are the new compliance capabilities which are getting added into the cloud in the next another before H2. Okay, so we have the timeline also coming in. So this is the secure portion, and next comes my analytic capability. So we can see the Qlik Cloud dash or the landing pages are keep getting enhanced day by day. If you see the image on the right bottom, initially it was only home, catalog, and then the create button was on the right top corner. So now the create moves to the left. And eventually we have a grouping factor, the second level grouping, where we have visualize, analyze, preparing the data. So that is the data flow. And then we have the ML capability, which is Qlik AutoML, Qlik answers coming in, automate, and then the task, everything is coming in a single window. So all the analytic capabilities are coming in. Similarly, for the integration also, all the when the user logs in, if he is more on data integration user, he will eventually be able to use the integration capabilities on a single screen. Okay, so what's coming up next is basically like we are going to have like a fine granular search and also more coming on. I will add into the next slides. Yeah, next slide, please. So this is update that happens in November, December. I think some of your users are already using heavily on end printing. So now we have the Qlik Cloud reporting, which has both pixel perfect and also Excel reporting. So the single term we are using is as a cloud reporting, which have both capability. And there is a end printing SaaS readiness app, which got released in January, where we tested with few of our customers, our existing partner. It's very much ready for the business user. Still, there are some gaps, which we know. We can work with the partners and the end users to get all the cloud reporting done correctly. Okay, we can move to the next slide. Yeah, so this is a big one. So we have the unstructured world and we have the structured world. So the unstructured world is your PDF help document and all that. So right now we are having it like Qlik answers and then the Qlik insight advisor for the structured data, Qlik answers for the unstructured data. And during the last meetup, ARMS was presenting about how we are going to bring it together. It's happening now. We're going to get it into an agentic AI, where eventually you will be able to have the assistance across the system, both structured and unstructured data. So this also goes with your insight advisor answering you the data. And the same time, you're going to get insights from LLM coming up from the Qlik answers on your unstructured data. And this is going to be released in our Qlik Connect. So we encourage you guys to sign up for the Qlik Connect, and eventually you can see it in first hand before it comes up to our territories. Next slide on. So this is just a teaser. You are having a big talk coming up with Boon, gonna talk much more. So just to say that Qlik took over this company called Absolver. Absolver is like they are doing a lot on Iceberg, on the open data warehouse concepting. So this is getting integrated into the Qlik Talent Cloud or the QTC framework. And eventually this is getting launched in our Qlik Connect. So I have a Qlik Connect dates, and also like there is a link on how you can register and join for the Qlik Connect. If you guys are looking on, you can also work with Satish, and he can see how you can get your passes for the Qlik Connect. Okay, we are having more things coming up in the Qlik Connect. Yeah.
Okay. All right, Satish, free passes.
I think I covered up all.
Next.
Yeah. Okay, so that's more from my side. If you guys have more questions, I'll be happy to stay on the line. If not, my colleague Satish and Jeff is over there. They will be able to take on. Okay, I'll sign off from here, guys.
Yes, great. Any questions? I actually have one about end of life, end of sale, and I'm not sure who is the best to answer it, Because like Data Stage, when it was bought by Qlik, a couple of years ago only, was it? Maybe in 2000.
Okay, the
Yeah.
catalog was like way before, I will say like 2014, 13, 14. So you're talking about the podium, which
No,
becomes the Qlik
it
catalog, right?
it can't be 14 because ClickSense started only in 2014. So that's why I doubt catalog
Okay, I
started
can
that
get you
time.
the date. I have another slide in which we have all the history of product line.
Yeah,
I
yeah,
can
but
share that.
the question about other thing, basically, how can actually clients rely on the technology that was brought into Qlik, and suddenly you need to switch to something else because implementations costs, they are not small ones, aren't they?
Okay. To put it on, so
Yeah,
what actually happening is we instead of calling Qlik catalog, you know that we have three catalog at this point of time, right?
yeah,
So we have the
that's the
Qlik
thing.
catalog, and we have the talent catalog, and we have the catalog in the cloud, which is basically like data, a smaller version, and then we have the data product catalog. So what actually happening is all the features are like getting into a merger. So instead of saying that Qlik catalog is getting merged into the Qlik data product catalog,
Hmm.
we just want to say that because the capability of the Qlik catalog, what it was is only on the analytics space, right? So when we took over the podium, it was more on like at that time we don't have talent, at that time we don't have the end-to-end capability. So it was focused on analytics only. So now, if you look over the Qlik cloud, the Qlik data catalog, which comes along with the cloud, we have all the QED profiling, Excel profiling, and even much more from the file perspective as well. So what happens is it is cloud and getting all the features enabled over there. Functionality wise, users will get, and also with the new pricing model, I'm not discussing it today because it is getting released in 2 weeks. I will not say 2 weeks, it's next week actually, it is getting released, where we are getting more capabilities available to our analytic users on the cloud, right? So once that is launched, maybe in the next meetup, we can share you on what are the
Yes.
capabilities available there and how it is available together for the users.
All right. Thank you. That's okay.
Sure.
That was it is philosophical question, what we should invest money now and what we shouldn't. But anyway, thank you very much, Ajay. Any other questions?
Okay. Thank you guys. I stay off the
Thanks,
camera.
Ajay.
Bye, Boon.
Hi, everyone. My name is Boon from Boon Solutions. We're a Qlik Elite partner, Amazon, Microsoft, and lately Databricks. So we're just going to talk a little bit about Apache Iceberg. What is it? Why is it so popular? And why is everyone raving about it? It's quite a simple concept. So before we go down that path, we'll just talk a little about the whole data lake, data warehouse, and why lake house. So a data lake is pretty much a collection of files. You dump everything in it, structured, unstructured. So think about from a very layperson term, CSV. Obviously, you got open format like Parquet files, and if you're in the Qlik world, QEDs, right? And that's stretching a bit because QED is not really open format. So you just dump everything in S3. Right. From there, you can go, okay, now I've got S3, all the files are there. How do I go about working with it? So then we just skip that for a bit. Data warehouse is your stock standard SQL database, right? If your SQL database, for it to work, you have to turn it on 24/7. That's where the cost comes. With Data Lake, if you're not using it, if you're not extracting the files, there's no cost to it. The only cost that you pay is storage, right? So now with the Lake House, is you're trying to take advantage of the cheap storage, but the performance and the query engine of a warehouse, hence it's called a lake house. Okay, the most common format at the moment is Parquet, and Qlik has recently supported the output. Instead of saving to QEDs, you can now save to Parquet files, and because Qlik can now write to S3 or AD, whatever the Microsoft equivalent is, I don't remember now, I'm so sorry, that you can save that there, and then you can set the Azure Synapse, Glue, or whatever it is to access that, even Databricks, even AppSolver. Because at the end of the day, we'll go deeper into what Iceberg is and why is it so advantageous to customers. Okay. Alrighty. So let's skip this for a bit. So Iceberg is just an open table format. Think about CSV. That's we all know it's the comma separated file, right? So it's not a service. It's not a storage engine. It's not an execution or query. You can't say, how do I access my Iceberg files? Generally, it's not supported. What you need is what we call a middleware or a query engine that manipulates and work with those Iceberg files, right? So how it works is pretty much, I'm just going to go down to a very simple term of CSV. You have multiple CSV here, multiple years, and it's stored on different folder locations, right? They'll work it out themselves. So now you need a catalog. There are different types of catalog to tell you where those files are. We like to use Nessie, N-E-S-S-I-E, because it gives you Git-like manipulation or management of those files. I can pretty much say, this is my main branch. I want to make, after my main branch, I want to make another branch because I want to test my ETL. Now you have another copy somewhere. You can work with it while the rest of the reporting tool is still working on the main branch, just like how you have your Git code. And when you're done testing, you then merge those two systems together, and now the user's no none the wiser because it's pretty much there, right? Now, if we then swap that over to Parquet files, now in terms of Parquet, it's just another standard format. If I save it, let's just say I save a file and it's got 3 years worth of files in there. What Iceberg, the open standard, and some of the tools, it can do what we call hidden partitioning. I no longer need to sort of partition the data down to months or day. So if you look at it from a Qlik perspective, if you want optimized read, is either you store a full file and don't do anything, just read the whole thing from start to end, if you're 10 years worth of data, or you say, I will save 10 years worth of QEDs, one for each year. And then you read which one you want. But what happens if you want a day or a week or a month? Parquet, not Parquet, but Iceberg, and some of these tools, they will hiddenly repartition the files for you, so it's a lot quicker. Right. Some say, is it slower or faster in the database? I leave that up to you, right? If you're in financial trading, yes, full-blown database. But if you're talking about, I want to read 10 years worth of data versus 1 year, there are advantages to this design, right? Because I'm now reading a much smaller file versus I'm reading 10 years worth and trying to filter it out, okay? And what does the middleware do? Each time I run a query, it will say, okay, where are the files? And you read those files. And some of the middleware, what they do is, because someone asked the question, I've cached those results. And I'll just return the value straight away to you without even reading those files. Okay. Absolver, Spark, Dreamio, Think. There are a lot of middleware. We call Query Engine that can help you with that sort of thing. Absolver is known to be more on the processing data. It's quite quick. I think it's about 6 million or 30 million per second. But Spark is where most people are more focused on. It does pretty much everything. It's a jack of all trades. Any questions so far before I go to the next slide? Are you good? Why Iceberg? Remember, if you're trying to save a CSV and your report's trying to read it, what happens? Right? Because then the whole point about reliable atomic operation, right? So the idea is, it's not, most of the file system is not what we call copy on write. You do not make another copy, overwrite, and then put it back. So if you save a CSV, it will try and overwrite the existing CSV while your report's trying to read it, it's going to crash or error out. So this is the good thing about Iceberg. Every write is a snapshot. Okay, so whilst you're saving the file, the reports are still reading the old one, the complete set. And what that means, because every write is an Iceberg, you need to do some maintenance. But the advantage of that is, I can take a snapshot and say, keep the snapshot for the end of every month. So when you run a report, you can always travel back in time. Okay, that's a very important thing as well. If you change your schema, there's evolution, so you can go back in time as well. So the reports won't break because there's traceability. We talk about hidden partitionability, multi-engine support. This is where the advantage is for the clients. You own your data. Iceberg in Iceberg form or Parquet files. So now it's up to the providers, the middleware, the query engine to compete for your data. Because today, if you don't like Spark or Databricks, you can jump over to Snowflake or AppSolver, because at the end of the day, all they need to know is what catalog are you using, and the rest can pretty much go with it, whichever provider you want. Okay. When not to Iceberg. So if you're already on Databricks and you're already on Delta Lake, I don't see a reason why you should move over to Iceberg unless absolutely necessary. If you have a small data set, if you just reading one QED files, I don't see the need to move over to Parquet, and because the metadata overhead is just not worth it, right? You have to have a massive big amount of data. That's why it's called big data. Like I said before, Qlik, Power BI, most of the Power tools can't connect to Iceberg directly. It needs to go through a middleware. Hence, there. And if you have a specific need to manually partition your files because you want the best performance, as opposed to letting them do the automatic partitioning, and you have no need for rest versioning because you reload your QBD once a day or once a week, there's no racing conditions, then you probably don't need that as well. Okay.
What is the big data here? Like for when it tends to start with this item? When is the data is big? How many rows per day, per minute, per whatever?
Well, ask me, I'll say probably let's start with 20 gigs, maybe 40 gigs.
Yeah, I'm talking about data volume.
Yes.
I'm talking about the maybe rows.
Rows.
Yes. Because I think
That's a hard one to quantify.
at least
It depends on how much workload you're pushing through what you're trying to do. So yeah, I mean, QVDs alone, you can handle 1 billion rows with no problems. Right, so
1 billion rows, it's a big data or not?
no. I mean, yeah. Well, big is a very subjective thing. But we talked about when you have multiple data like SAP, and let's just say connected line, PitRem, or even your processing plant stuff. There's billions of data going through. Then you need something like this to partition it automatically, do it for you.
But basically, if it's less than 1 billion rows, I don't know, a year or whatever you're trying to analyze.
No, because 1 billion rows, the database to host 1 billion rows is really nothing. Right. Yeah.
I mean, for many people, it is something, 1 billion rows, but
yeah.
It's actually not that much.
No, but I would say if you have 1 terabyte worth of data, I think it's probably worth looking into it. But still, there's level optimization. You can still stay away from this, right? But then when you try and democratize and make everyone's like, I want my report now, then you need to start worrying about, reloading, scheduling, and all that. So now it's okay. You have this the classic one, right? I would pick Power BI. I'm not picking Power BI. Or Qlik, doesn't matter. You run a report and it summarizes all the transactions. It says 1.1 million. 5 minutes later, you say, I want to drill down. As you drill down, because someone already added me a few more financial transactions, it's no longer 1.1, it's 1.2. So when you drill down, all of a sudden it's from 1.1 to 1.2, then the CEO will be like, or CFO will be like, well, the reports don't match. But if you take advantage of this and go, when the user looks at the summary, that's the snapshot. And then when you drill down on the same snapshot. So you're safe. But we can still do that with Qlik. We say, okay, when we build the summary, we make sure these are the transactions, and then the QED will be that. So there are always ways to try and mitigate. I mean, this is not the silver bullet for everything, right? But it really simplifies a lot of these.
And for smaller customers, it doesn't make sense.
No. Because the smallest customer, all you need is Parquet files. You just store it into S3 and then Qlik and connect to it, or Qlik can store Parquets, and you can use that as well if you want to store it as an open format.
Yeah.
And there's no stopping you from saying, instead of you do all the business rules in Qlik, save it in QBD, and then go, okay, and then come along a Power BI person, I need my report in Power BI. So, right, I would now, instead of saving to QBD, I would save to a Parquet file, dropping into Azure, and then surface that data to you with Azure Synapse Serverless. And then now Power BI can connect to that, and then you have reports. There's so many ways to do this.
Thank you.
think that's about it, really. Good.
Any questions? That was my question.
Yes.
Yeah, when you say we can now work with Parquet files, is that only Qlik Cloud or is it Qlik Enterprise as well?
Oh, I can confirm Qlik
that's a
Cloud.
good. Yeah, Qlik
I
out.
think Qlik Enterprise needs to be a newer version. Yes, pretty confident.
Yeah,
I need to get back to you on that. Yeah.
It's been able to write out Parquet files for about a year now.
Yeah. There you go.
Do you need to have a
On
great,
Enterprise?
great?
In Enterprise or Cloud?
They're on
Enterprise.
Enterprise.
So you've got three options. You can write out QPD, CSV or Parquet file.
Yeah.
It's the same store command, but just with a different.
And then Power BI can read it.
Yes. Yes. So
Especially if you store it in a SharePoint, or like OneDrive.
well,
You were just talking about it before the.
I would recommend you put it into Azure Blob.
Yes.
And then have Azure Synapse surface that.
Yep.
Because at the end of the day, the users are more familiar with queries, right? So Azure Synapse, we put the query in, it will then read the Parquet files. Now, because you're going directly doing Parquets, you potentially partition those files. Because if you have a huge amount of data, you might want to go, okay, I filter it by year or by month or by site. So that when the user runs a query against your Parquet files, it's not going to go read everything. And then you know how the cloud system works. Depending how much what you want it to do, reading inclusive, that's where the, right, so.
I had another question.
Mm.
As far as the demand, clarity, like from a customer base, are you seeing a lot of interest in this, or is it kind of?
I think because it's the open format.
Yeah.
I think it opens up a lot of possibilities. And I think, because this is recorded, I'm not going to say too much, but I believe Snowflake is going to struggle a little bit. The Snowflake do support Parquet, but that's how some of these big cloud databases is how they make money, right? You keep the server up and running, that's money, and then you run an inefficient query, that's money. So, but if you put everything down into Parquet files and optimize your queries, you get better results, better outcome. So the story about the tagline for Iceberg is, or Lakehouse is the price of S3, but the performance of a Lakehouse. Don't quote me on that. So there will be some disadvantages as well.
I guess the other side of it is by having a standard like that, creating a more competitive environment, just those middleware players,
Yes.
and then you get other smaller players that come in with a niche
Yeah.
capability that you can then pick and choose when to use what middleware tool based on your use case.
Correct. And Apache Spark is open source. So if you want to do things manually, in air quotes, you can go down the path of Apache Spark. But if you want better management and all, fancy stuff, Databricks is running on Spark and supports Iceberg. So again, commercial support versus open source and what you want to do with it, right? And there are different engines. Upsoul is really, really quick in certain things. Dreamio is really good at some things. Spark is more of an all-rounder. So
I guess the other side of it is if you get disgruntled with a particular middleware provider, it's easy to do this.
you can even write your own, yes, sir. As long as you comply to the spec. Well, if you write your own, you don't have to comply to the spec anymore, but yeah. So there you go. It's where it's interesting times. Yeah. And plus, there is an open source equivalent of S3. So if you want to have it in-house, you can run MinIO or Minio. The only difference between that and your S3 is S3, they can do tiering. So if you want high performance in like the first 3 years, you store in the fast tier. As your data gets older, you will store in the slower tier. Minio doesn't have that. That's the only difference. Other than that, fully compatible. You can keep your data all in-house.
So now we have Justin from IGO who will share experience with Qlik. Yeah.
Yes. There you go. So, hi everybody. Richard asked me to come in today and give a talk to everyone about how we utilize some of QlikSense capabilities in the use for like mineral exploration. So IGO is a lithium, copper, nickel explorer and miner. I work in the exploration group as a senior geochemist, and I deal with geochemical assay data on a daily basis. And depending on where we are at in the exploration value chain, it's either very slow or very chaotic, depending if you're just looking for something versus you find something and you go from drilling a few hundred meters, few thousand meters a week, month, to drilling tens of thousand meters to hundreds of thousand meters. Your assay volumes go up exponentially. So we need to be able to handle the QA/QC or quality control of those assays in a very flexible way. And it has to go from the bare bones, very early stage stuff, all the way up to like mine site drill outs and resources. So I think it was about a year and a half ago that I approached you to work on this project. And it's been a working project for about 6 to 8 months. And then we got to a finals product, but basically encompasses a bunch of different aspects of QC that really make things easier and frees us up from having to do QC through, say, Acquire. And this means we have access for all of our exploration geologists. So it's not just 1 or 2 people that are doing the QC, everyone can be taught to do it. So it really helps it. Next one. There we go. Okay, so just a little example of why we do QA/QC, or an introduction to how exploration and mining does QC. Essentially, we're taking these geochemical samples and we need to ensure that we can reconcile them, so where they come from. We also need to see if they've been sampled very cleanly, and whether or not the preparation that was involved to get the analysis from that sample was done in a clean way, so that you're not contaminating samples. So say if you have ore grade lithium samples that are running 4 to 5%, when you're pulverizing that sample, you can get carryover to the next one, and that can smear the actual assay grade across an interval and create discrepancies in your resource model. So you need to make sure that the process at which these samples are going through is very clean, and you can reconcile every bit of it. Another aspect of the QC that we look and analyze and monitor in this way, so we look at the accuracy and precision of the analytical methods. Now there's a bunch of them, and in geology, there's thousands of different ways to analyze a rock to get a number, and some are better than others, and some are all essentially the same, just slightly different. Some are more precise, some are more accurate, some are better for certain elements. It's a tailored approach, and you have to build your assay method and your QC accordingly to not only the mineral deposit style, but also what exactly you're trying to get out of that rock itself. So some of the common things we use are standards and certified reference materials. And essentially those are geologic material that's been analyzed by several labs. And then all of these labs provide that data, and they come up with consensus average value of what the value of the chemical elements are in that rock, as well as the variance, like how variable is that material. And that's just to see like how homogeneous that medium is. Now, basically you take tons and tons of rock and you pulverize it down into very fine grained material. In that case, you're hoping that it's homogeneous, and it's very difficult to achieve that, but most analytical facilities now that prepare standards are pretty good at it, and Qurious is the one that we typically use. We also use blanks, and now blanks can be certified, or they can just be a material that doesn't have a lot of the elements we're interested in. So in this case, if we're looking for lithium, we might just use quartz sand as a blank. Doesn't have any lithium in it. So that's easy to put through the preparation method, and it actually helps determine how clean the pulverizing mills were before each sample goes through. We also have duplicates and replicates, and this is used to look at analytical precision and reproducibility. And you can do that in a number of ways. So you can split a sample, or you can take samples that are adjacent to one another, and they have in themselves variation, but there's a certain level of acceptable variation. And also we have laboratory checks. So we do audits and umpires where we actually send pulps that are from one lab, send it to another, and see if they come up with the same number. And we then compare that data. So some of the most common things we do is we use control charts. So these are very simple plots, and I'll get at that on the next slide. But what I want to focus here now is essentially, this is a very simplified workflow, a very generic workflow of how we collect samples. Essentially, either are sampling out in the field, collecting rocks on the surface, or you're taking intervals from a drill core and you're creating a geochemical sample. Those samples normally form a batch of about 250 samples. You insert QA/QC standards, so a CRM or a blank, or sometimes you do a duplicate sample at roughly a frequency of 1 in 20. That's what we do for exploration. If you're trying to be a lot more fastidious in mineral resource, you might go a higher volume of QA/QC. So it can be quite a significant additional cost. Then once all this is put together, this forms a sample batch, which is submitted to the lab. And that lab, we've referred to this assay batch now as a lab job, is received by the lab, and they process the samples and analyze it. During all this, we want to track the process, and the lab has a live feed that feeds back into our database, and we're able to see where things are at, where it's coming out of the field, when it's hit the lab, and when it's in process, and when it comes back to us. When the data comes back to us, it has to get QA/QC'd. So we have to make sure ourselves that this has passed all our QC checks and we're happy with the accuracy of the data. And a lot of the labs now, about probably 20 to 30 years ago, it was a lot more common to have QC issues, but a lot of QC work has been done at labs. And the lab we use particularly is ALS, sometimes Bureau Veritas. They have very, very, very strict QA/QC protocols, and we rarely find issues, but every so often it does happen. So this is why we do this. So with the QA/QC, this is where Qlik comes in. And essentially, we run it through this dashboard, which allows us to look at a lot of different elements all at the same time very quickly, and then we can then accept it and enter it into our database. So here's just an example of the control charts I'm talking about. All they are is time series charts, and you essentially have a median line, or not median line, an average line, as well as have your 2 and 3 standard deviations. Now, the first one that we deal with are control charts, and essentially these lines are defined by the values that are derived from the certified reference material. Now, in this case, you're looking at something with about 5.6%, 5.8% maybe, magnesium, and you can see our data points are trending below that average. You would say, okay, well, the lab's not accurate. True, the lab's not that accurate, but it is within the 2 standard deviations, so it's still fairly accurate for our purposes, especially for an element like magnesium, where I'm not too fussed about a 0.5% variation. The other way we look at it, and this is how we typically look at exploration data, especially in small data sets, or once we start to get 20 or 30 data sets, this really becomes the most powerful tool, is we want to isolate the exact process we're trying to monitor. So the data that formed the average line for the certified reference material was done, say, by 20 or 30 labs, and they came up with this number. Now, the method you're using is probably not the same method that they used to actually get those numbers. So your values might be slightly different, and that's called bias. It can be positive or negative. Now, when you look at a SHIWAT chart, what you're doing is, instead of looking at those CRM values, you're looking at the running average, or essentially the performance of that specific method at any given time. And that's how we generally deal with all of our data, or at least our QCRD data initially. When you're getting to a resource stage, you use the certified reference materials as well as umpire audits to determine the amount of bias in your data, so you can actually adjust and make sure that your assays and your ore grade shells are as accurate as possible. So the QlikSense QA/QC dashboard is comprised of essentially 3 main parts now. We have the landing, which is essentially our tracker, how we keep track of assays that have gone to the lab, have been returned, and are actually waiting for QC. And then we have the ones that have been accepted. So you can always go back and look at things. We also have the control plots, and that has the control plots with the CRM values, as well as the SHIWAT data, as well as we have duplicates, which is a separate workflow because you have to handle the data slightly differently. Now, the good thing with this is we can set up templates for every project. Say we had, at this point when we were doing this, we had about 12 projects going. Each one was looking for different commodities, and they cared about different elements. So you needed to have different standards for every single one, most of them actually. And then you had to have them QC certain element suites that you really care about. So instead of having a geologist have to think about the 30 elements they need to look for, we just made templates for them that allowed you to just move through it quite quickly. And with the app here, because it's not acquired, you don't need a license for it. So they can essentially sign into our portal and then they can actually QC it anywhere if they want. They can do it from home, they can do it from the field. You don't need to have an acquire license, and it is actually a massive cost savings when you only have your acquire licenses doing the database management versus someone having to hop on to actually do QC. Once the data is approved in this workflow, it essentially goes through an FME pipeline that then approves it, and it goes through into the actual acquire database and then is in our data exports. And yeah, the real benefit here was the no limit access. So I'm going to just touch on briefly when I talk and go through the duplicates and replicates per application. Some of the terms that I use is limit of detection. Essentially, that is the value at which below that, it is very unlikely that you're going to be able to detect that element, or statistically almost meaningless. So essentially, analytical facilities have detection limits on their assays that they've determined that essentially below that, about 95% of the data, like the variance is so high that it means almost nothing. So these lower limits of detections are the bare minimum, and they show up as negative values in your CSV that's sent back to you. When you're dealing with duplicates, we refer to them as parent and daughter. So essentially parent as the original, and then your daughter is the second one, either the one that's split from it or it's something that's taken from a very similar location. What I'm worried about is looking at the value of the element that they're reporting back to me and whether or not the detection limit is far enough away from that value to be meaningful. So if we look at this data here running down these columns, I'm looking at silver. So it's silver and underscore method underscore ppm. So you're dealing with a lower detection limit of 0.0002 ppm. The parent had 0.043 ppm. If you divide the parent value by that lower detection limit, the detection limit ratio is 21.5. That's actually quite good. So normally when you start to go below a ratio of 10 down to 5, the actual error in the variance of that can go up very high. And when you compare it to a daughter, sometimes those numbers are very far apart. They could vary like 50%. Sounds like a lot, but when you're dealing with fractions of a ppm, it's not so bad. And depending on the element, I'm not always concerned. Here's just a few other examples of some of the arithmetic that we're looking at. We have the parent-daughter limit of detection ratio, the daughter, and then we have the relative difference. So this is comparing the parent and the daughter variance, like how much they reconcile. For limit of detection ratios, we use a stoplight system. So green for good is samples that have a ratio greater than 10. Yellow is okay, 5 to 10. Poor is less than 5. And then for the relative difference, we use the same stoplight pattern. Green is good for things that vary between 0 and 5%. Okay, 5 to 20, and poor greater than 20%. So that's essentially it for that presentation. But then I'll just run through the app quickly. So, hoping that my VPN holds true. All right, so here's our landing pages, and we have the Acquire QA/QC dashboard. And here we have the landing page. Essentially, this is where you go. Since this is sort of like the intermission part of our exploration, we don't actually have new assays coming in. Normally, this is absolutely full, and people are constantly going through it. However, we still have what has been accepted in the database. But it makes it very easy for someone to go in and just check. And if you're doing monthly reporting, you can quickly do an audit of what's in the pipeline and what has been accepted so far. If we go back and we actually run through the control plots, since we don't have current assays that need to be approved, I can't show you sort of the automated workflow that it pumps you through. So I'll just run you through exactly how things display. So I'm just going to bring up one of our many projects and focus on Forestania. And essentially, I'm going to bring an assay method in because I know what it's used for. In this case, I'm looking at soil sample data. And it's ALS assays using a 4-acid digest. So very aggressive acid that nearly totally digests that rock. And what we do is we now select a standard that we have, and now we have a control plot. What we're looking at right now is the standard. So this is your standard control plot. So all these lines are defined by the CRM. Our data is falling very well on those lines. And right now we're looking at majors, some major elements like aluminum, calcium, magnesium, iron, and so on. But we can also jump to other suites of elements. So I have immobile elements like niobium, tantalum, and all these things. I use that for detail with the geochemical analysis. Most people don't care about it, but I care about it if it's accurate because it can actually tell me a lot about the affinity and provenance of these samples. We'll just jump to lithium right now. And this just shows me all the lithium assay as well as the pathfinder elements that we use to look for lithium, or lithium, cesium, tantalum pegmatites. So here we have lithium is running around 14 ppm, varying maybe a ppm, so very good. Beryllium here, it's around 1 to 1.2 ppm, very trace concentrations. You can see here cesium. Cesium has a little bit of variation here. These are high flyers that we would go and just check to see if that actually is the proper standard. More often than not, the QC errors that we run into are our geos accidentally mislabeling standards. And all we need to do is relabel it and it all falls back to normal. So it's very nice and simple that way, normally. Sometimes there's more complex QC errors that we do pick up, and normally it's batch effects or someone forgets to add a certain acid that has happened, but very rarely. But most of the time it's just mislabeling the standards. So in this case, we're just looking at a regular soil standard, so it has very low ppm lithium. Now, you can also look at other analytical methods here too. So if I go to a different method, so what I'll do is just clear these standards. So I'm going to stay in Forestania, and now I'm just going to hop to an assay method that I know is used for ore grade analyses. So essentially, I picked ICP82B, and that is assay grade lithium, and I'm going to pick STDK64. So essentially, this is showing us.
One of my favorites, that one, STK64.
Yeah, that one. It's discontinued now, unfortunately. Yeah, they went through them. They blew about 48,000 standards in about 6 months because of the lithium boom. So they went through all of them. So essentially, when we're looking at our data, we can see that we have the standard values. They're pretty bang on. But we can also change it to Shewhart. So if we go to Shewhart, it changes to our running average and is set, the variance is according to the analytical method that we're using. Now we can see we still have these two out of control events that we then follow up and see if it's just an accidentally swapped sample. And I can tell probably from the variance, it's probably an out of control, maybe just a calibration issue, because it's usually far enough off. It's actually another standard, and you can tell, oh, it's 0.1%, not 0.2. It's this one. But yeah, it makes it very easy to quickly go through all these different elements and just make sure they're all accurate and fit for purpose. So now I'll just hop to the duplicates app. And I will bring in Forestania again because they were doing the most recent sampling. And what we find, I'll just select a certain lab job. So that just narrows it down quite a bit. Now, what you can see here is you have a ton of elements going on. Now, my brain works better in tables and using the stoplight system. A lot of original the way they used to do it before was they had a 1-to-1 plot, and they would have the parent versus daughter, and they'd have a 1-to-1 line, and you have like a 10 and 20% error cone that would be on it. You can do that, but it's one element at a time. This way, I can look at all the elements all at the same time, and I can look at the ones that are red. And it's like, green's good, don't have to worry about them. Yellow's okay. If it's not a key constituent element that I'm caring about, yellow's fine. The red is where I start to look, is it close to detection limit? And if it is, that's fine. Now, one of the steps I want to do in the future is automate a lot of these conditional statements, and then it can actually go through a lot more quickly. However, I found it very useful to use this as a teaching tool for geologists to actually get an understanding of why we're doing some of this stuff. And yeah, we just use this as a very quick way to look at our standards and duplicates. And one of the examples was, I don't know how they did it, but they somehow mixed up the sequence with the duplicate. And when the data came back, the duplicates did not reconcile at all on any element. It was obvious, big red stripe across the page. You say, well, you mixed up your standards, or you mixed up your duplicates. They went back and reconciled it. It was a pretty easy fix. However, if you were just looking at one element, say lithium, and you're looking at field duplicates in soils, sometimes that value doesn't vary that much. So you might actually miss it. So this allows you to look across all the elements, and some are more telltale than others. And yeah, essentially we do have the parent-daughter biplot, except for some reason we tweaked something and it doesn't work, but we'll fix that. Yeah, we did something today at the 11th hour and it stopped working for me, so I'll fix that. But yeah, it's other than that, it works very well, and you can actually publish these in report form, so it makes it very easy to do monthly and quarterly and annual reports on QA/QC. And yeah, essentially that's it for now.
Thank you.
Yeah, that's
One question.
Yes.
I don't know very much about geology. Or
Well,
but,
all good.
They just pick rocks.
Yeah.
When you're looking at this, and
Yeah.
obviously with a lot of experience, you can
Mhm.
start to identify certain patterns and you understand what the potential cause is for those patterns.
Yes.
Like you're doing that. Are you then looking to feed that back to the system
Mhm.
to then guide other users as to what the potential problems are that have occurred to make it easier for them to?
Yeah, so we do have an actual sort of like a list, like a history of all these things that have gone on.
Yeah.
Plus, I do frequent tutorials with just running through all the ifs, ands, or buts of QC. Some of this can be very subjective, especially with field duplicates and stuff like that, because it's not, there's always ifs, ands, or buts. However, yeah, we're recording a lot of this, and I prefer to do some of this manually because I know some other companies have tried to automate it and then have it automatically report back to the lab. And what's happened is they've put way too strict requirements on all of the elements. Not all elements are purposefully certified to the like the 10% variance threshold. Qurious has this thing called a super CRM. Every element's been measured. However, every element isn't as good as the ones you're worrying about, like say lithium. They focused on that element. Everything else is there. It varies.
It's always about context.
It's always about
Apply that
context.
to any
Yeah.
data set. Yeah.
Yeah, and that happened with one of the majors. They actually flooded ALS's QC email chain with all these rejected assay batches because they had too strict a thresholds. So it's context dependent. You have to make some very liberal rules on non-key elements, and you still need a person to look at it because it's out of control events can occur in many different ways, and sometimes it flukes that the numbers are actually the same, but something just looks different. So you still need someone to look over it. And this way we sped it up, taking something that takes essentially half an hour in a choir to look at 20 elements is now a 2 or 3 minute job, and you can do it quite quick. And they actually learn something from it. Yeah.
Well, for those that I don't know, Makushynski is pretty much the software in the geo world. It's interesting, you're monitoring so many elements. Most of our clients are just primary, secondary, at most tertiary. So what's the reasoning behind that?
Yeah, so one of the things that I started doing is I actually, when I first started with IGO, it was a very limited suite that we focused on. However, we use a lot of the other elements to help interpret the information that for the Pathfinder elements we're doing. Say, for example, niobium or tantalum or something like that. Niobium is a very resistant element. It doesn't dissolve very well. And if you don't get the digest right, you can underreport it. And in that case, if you're using ratios that use niobium, you need to make sure that's accurate. Most people never look at niobium unless you're in a niobium mine. Most, like in my case, I'm looking at soil samples that have like 10 ppm niobium. However, if your digest fails and it goes down from 10 to 5, it changes all your ratios and you make artificial populations in your geochemical data. And a lot of people don't consider that. And I've had an issue before where we had several batches where someone failed to put hydrofluoric acid in the samples, and they actually underreported even potassium because that doesn't dissolve very well. And when I looked at the data in IOGAS, so like a data visualization software, I saw this lung population. I'm like, why is that there? And it was because they botched the analyses. And the thing is, I wouldn't have picked it up in this app because it was between standards. So it was a weird little fluke. Now, you can also, probabilistically, usually the runs are in 13 or more, so you're going to actually have a standard in one of the runs that they dose. However, it was just how it lined up. Our standards were stretched a little bit thinner than they should have been, and it went right between them. And you wouldn't have seen it in the QC. So yeah, if we're trying to use this data to interpret, say, provenance, whether or not we're in a certain geologic domain, we use all these different lithophile elements, and then you have all your pathfinder elements that lead to ore. And we use all of these lithophiles to help get a lot more information about what we're doing.
Signal.
Yes, a signal, and it's a lot of it's with soils, it's all relative world too. So you need to make sure the elements you're using are all as accurate as they can be, or else you'll just be chasing ghosts. Yeah. Yeah.
So one last question is everything. Because the food and drinks are waiting.
Yeah.
But I have a question for you.
Oh, okay. Thank you very much, Justin. That was a great presentation. Let's come back to one slide and ask one question, audience. We will do it old style, like old fashioned. Do you prefer Thursday or Wednesday? That would be the question. And who prefers Thursday? Can you please raise your hand? 1, 2, 3. Okay. Who prefers Wednesday? 1, 2, 3, 4. Okay, it doesn't really help. What other people prefer? Not preference.
You serve cold beer.
All right, so there is no preference. This is like, who has no preference? Please raise your hand. Wow, okay, makes sense. Thank you very much. Now it makes sense. So we will, like, why I'm asking people here, because you are the people who are coming, but I'm also worried about people who are not coming because Thursday they working from home, need to pick up kids, need to do something else. So basically, I'm trying to figure out what are the.
Yes, my analyst would like to come, but she can't because she does her kids.
Yes, that's exactly.
It's late night shopping as well. That's good.
Actually, I was thinking to put it in mind too. In LinkedIn, it was saying just forget about your Thursday shopping. Come to our. Anyway, thank you very much. So, what else I've got to show you? So basically, if you have something to present, thank you, Justin. Thanks for. And thank you, Richard, for organizing all of that. So please reach out to us. And who are us? This is our committee members. They're all on the screen. Please reach out to any of us if you want to change something, you want to join the committee, want to say something, anything you think can be improved or changed, or doesn't matter. So thank you very much for coming.